So we've been solving equations with the addition property. And basically what you're doing is adding or subtracting numbers or terms to either side of an equation to get x's by themselves and numbers by themselves. We're going to continue on kind of dealing with where we left off, where we had a negative x equaling a negative number. And I said we're dividing by that coefficient to get that number, or get the x all by itself, so that x equaled 1. So that's what we're doing with the multiplication property. We're going to go back to some that are a little more intuitive. So this one says 6 times what equals 18? Well, if you were to answer that like a riddle or figure it out, you know the answer's 3, maybe. The way we get there, the strategy we get there, is to divide by the 6 and divide by the 6. You're doing the opposite in that you have 6 times x, so the opposite of multiplication is division. And so that's how you can eliminate the number that's hanging out with the x term there. We're solving this equation so that that's how we show that x equals 3. Always with these ones, we can verify left side and right side, sometimes worthwhile doing on a test. And that's where we can see that the left side does equal the right side, and that we know that x equaling 3 is a solution to this equation. So in all of these, we're practicing the multiplication property. When you solve equations, you do them kind of in reverse BEDMAS order. So start by adding and subtracting terms and then move on. Your final steps would be dividing or multiplying these terms. Okay, so in this one, I'll say that one again. We're dividing by the coefficient. 7 divided by 7 would give me just an x. But then on the right-hand side, we get that x equals a negative 6. And we can double check that. We could verify it. It tells us to, but it takes up a little space. And intuitively, you can look back and see that that is the answer to this. So again, with these ones, what we're practicing is dividing by the coefficient to isolate the x. Such fancy math talk. It's probably not what you're saying in your head right now. If the coefficient is a negative number, then you divide by a negative number. That's what we were doing back in that last example on the earlier page. So negative 9 divided by negative 9 gives me an x, and the right-hand side gives me a 6. Whoops, and I missed my negative sign there. So it's a positive 54 divided by a negative 9 gives me a negative 6 as an answer. So that, in a nutshell, is the multiplication property. Usually the final step when you're solving things. Occasionally we do have things like this, where you have fractions. And so in these ones, the opposite, if we want to get rid of this over 3 bit, it's being divided by 3, so we get rid of that by multiplying this by 3. Well, if we multiply this side by 3, then we also have to multiply this side by 3. In this, we'd have 3x over 3, or we could think of it as simplifying so that we just have the x equaling 18. If I were to check this one, and again, this is one that's intuitive, you should be able to kind of just look back at it, but x is 18, right? That was our solution. Divided by 3, it should equal 6, and if we sub it in, it does. And so verifying my work tells me that that x equals 18 is an answer to this question. So these ones have, division going on, so we're practicing doing the opposite. You're isolating the x to get the solution to this equation. So again, what's going on here is division. The opposite would be multiplication. I can't just multiply one side of the equation, I have to multiply both sides of the equations. If you multiply one child by 3, you have to multiply the other child by 3. that whole like giving the kid 3 cookies and the other kid 3 cookies starts to fall apart, where you're supposed to divide each child by 2, because that's not fair. Okay, sorry. I can't make jokes when nobody's listening to me because they just don't make any sense. So we end up with this. I know you're listening to me, but I'm sitting alone in my office right now making this video. Things aren't as funny then. Okay. Once you get on a roll with these ones, they are very repetitive. I think the trick with this is when they get all muddled together, right? So hopefully this pattern, what you're recognizing is there's a commonality. We're trying to get x by itself and numbers by themselves, and you can do it by doing the opposite operation to whatever is stopping you from having x's by themselves and numbers by themselves. So these ones are even more confusing. You can multiply by the reciprocal, or we could just do this in 2 steps. We're going to start by getting rid of the denominator, doing like what we were before, right? Multiplying by 5 on both sides. If I do that, I still have the 3 times x, or I could think of it as 3 over 1 times x. It looks a little more sane to just write it as 3x equaling 45. Now this last step is to divide by 3. Remember, we know to do the opposite. So here we have dividing by 5, so we get rid of that by multiplying by 5. Here we have multiplying by 3, so we get rid of that by dividing by 3. That gives me then that x equals, you pull out your calculator, a 15. This one is possible to verify. It's, yeah, or we could do it the other way. So I'm going to switch colors, because if that way works for you, then by heaven's sake, you don't have to do it the other way. So what it means by this reciprocal bit is saying if we have 3 over 5x equaling 9, we could just multiply both sides by the upside down version of this fraction. So 5 over 3. If we multiply this side by 5 over 3, then we have to multiply this side by 5 over 3. In this case, the 5's cancel, the 3's cancel, and we're left with just the x. Then we have the fraction math to do on this side. I am a fan of breaking it down and doing it small steps at a time, but I thought I'd show you this alternate approach in case you're somebody that is already, partway through with this understanding. So we get either case that x equals 15. Either way, I'm going to switch back to the blue pen because I think that's the way that I tend to do this. I start out, I'm going to multiply by 3 to get rid of that divided by 3. Anything I can do to get rid of fractions, I'm going to do because they honestly make things look a little more complicated than they need to be. So now I have a statement that's a little bit easier to see what's going on. And so I divide by 2 to get my answer that x equals 12. And again, if I wanted to verify this one, I sure could. So this one I will verify instead of showing you the other way to get to the right answer. It has a little bit of fraction math in it. So 2 times 3 times 12, or I can think of it as 12 over 1, should equal 8. If I do the fraction math, I'd have 2 times 12, which is 24, divided by 3, which is 8. So however you get there, however you verify your work, this is the extra little bit. So we're going to practice a few of those, and then we're going to combine the rules. So if you're a little bit rusty on your math, or you didn't do it my way and you want to try it on your own, then go ahead and fast forward or pause, whatever it is. I'm going to show the work the way that I was just saying. I think it works best for me. So I'd start by multiplying both sides by 5, and then I move on to dividing both sides by 4 to get rid of that 4. So I get that x equals 10 as my solution. The last one with fractions, I'm going to get rid of those fractions first by getting rid of my 2. 2 divided by 2, I could simplify it, right? So that's where I get the 3x, and that equals 18. Now move on, divide, I get x equals 6. So combining these rules, the names are kind of funny because the math books teach it as the addition property. Well, that means you can add or subtract numbers, and the multiplication property. And half of the time you're actually dividing. So maybe those names aren't the best, but we do have those kind of 2 different families of operations that we've been using. When you have to solve an equation, I always start, and you should start, with adding and subtracting things and then finish usually by dividing by things to solve. So start with adding and subtracting and then divide. So for A, I'm going to start by moving this 5 away from what I want to be the x side of my equation. I don't want 5 on this side. I'd copy down, I'd have 4x equaling 12. Now I knew there was a 4 in front of this x. I'm going to get rid of that by dividing, but you can see I did the adding and subtracting first, then I do the dividing after to finish up to get my final answer of x equaling 3. And when you're combining the rules, prioritize. I always say that solving is kind of like doing reverse bedmas. You're trying to kind of reverse engineer these to figure out what x actually equals. You could check on this one. My answer key actually shows the verification because it tells you to. I'm going to skip it in the video here. So the next one, I'm going to start by adding and subtracting numbers. I have a plus 9 hanging out over here where I want just x's. So I'm going to subtract 9 from both sides. That would get rid of the 9 on this side, so I'd have just the 6x equaling negative, what is that, 24. Then I divide both sides by the 6 to get rid of the 6 and get just the x equaling a negative 4. I almost missed the negative number on that one. If you want, you can try the next ones and then let the video play, or you can just kind of walk through with me. So I'm going to start in these ones like I have been. Now you can start with whole numbers if you want, but I am definitely going to start with adding and subtracting things. So previous to this section, I was starting with the x terms. So moving the x terms to the left, I'd get 6x minus 3x. I'd get a 3x, and I'm just going to copy everything else. Some people learn this stuff doing more than one step at a time, but I kind of slow it down so that you're only doing one step at a time. I know eventually I'm going to have to divide by 3x, but I'm going to finish up with the adding and the subtracting of stuff, right? So I get now that 3x equals a positive 2. It is possible that these work out to be fractions, so don't be scared if that's what it is. It makes me really not want to verify this one. Again, in the notes, oh, I did verify this one in the answer key. So if you want to see, you can see the answer key. I think I got to that and I'm like, oh man, who would want to verify that? So check that out if you like. In D, when I approach this one, I'm going to deal with the x terms first. I'm adding and subtracting before I do any multiplying or dividing stuff. I'd have negative 4x. I'm going to copy everything else. I'm going to subtract 3 from both sides. Just trying to get x's on one side and numbers on the other. The last step is to divide by not just 4, but negative 4 to get the x all by itself. So I get that x equals a positive 6. One thing in these ones, when you start mixing the rules, sometimes people don't notice the difference. So when I put this big line here, what I'm doing is adding and subtracting things, right? That's underneath everything. This line is like a divided by line. So this is kind of like your total, where you add 4 plus 6, right, equals 10. This is like saying negative 12 divided by 2, right? So this is a total and this is a divide by. So yeah, just watch those two lines. They can get a little muddly in your work, but I try and be consistent with them. Okay, so the last two here have distribution in them, or distributive property. So until you deal with the brackets, you really can't move on in solving anything. So we need the distributive property to bust up those brackets. And then I'm just going to copy everything else. You can combine steps. We're going to try and do them as I can. I got some like terms to combine or gather up. So I'd have 3x minus 15 equaling x plus 7. After that, then I'm going to pick on my x terms. I'm adding and subtracting things. Hard to cross out x's. 3x minus x gives me a 2x. The rest is just coming down to be copied. Now I'm going to add 15 to both sides. That gets rid of it over there. So I've left with just an x term on that side. And what is that? 22 on that side. It's a little bit squishy. Oh, what did I just do? No, that's right. Oh, I've got a mistake in my answer key. That's the problem. I'll have to fix that scan. So I get that x equals 11 here. I hope I didn't make another mistake in there. You'll have to let me know if I did. Okay, so another distribution, I'd have 7x, and then 7 times 5 is plus 35. I'm copying out the other stuff. I'm going to combine these like terms, so 4x plus 35. I'm scanning the other one to see if I made a mistake in it because it didn't match my answer key. We'll go with it. Let me know if you need some help. Okay, then I'm going to pick on the x terms first. I'm going to subtract x from both sides because that's what gets rid of it over here. So I'd have 3x plus 35 equaling a negative 7. I'm going to keep adding and subtracting. I'm not done yet. Don't jump the gun and start dividing or you're going to get a bit messed up. So I get 3x equaling negative 42. If I pull up my calculator for that one, I get that x equals a negative 14. I think it's a good idea on these ones to maybe take an example, and you could add this to your formula pages that explains what you're doing. So the first thing you're doing here is distributive property, which basically busts up the brackets. The next thing that you're doing here is combining like terms. After that, you move on to adding and subtracting things to move around. So you add or subtract. I'm just going to put subbed. Move x's to left and numbers to right. Basically doing the opposite so you can cancel this stuff out, right? After that, the last step is to divide by coefficient, coef, I'm going to write on the x. And so by having one of these where you kind of, show all your work, do one step at a time, but also explain to yourself in your own words, however it makes sense to you, what you're doing, it can really kind of lock in your approach in your own words and the way your brain makes some sense of it. If you need some practice with these ones, let me know. Sometimes this is a skill you remember, and sometimes this is like all brand new, or maybe it is something you've never done before.